More rules of exponents. Let's look at the product rule and power rule. Remember, an exponent can be used to show repeated multiplication. 5 to the third power. 5 is called the base, 3 is the exponent, and we interpret this to mean 5 times 5 times 5. This expression is said 5 to the first power. 5 to the second can be said as 5 squared, and 5 to the third power is said 5 cubed. To evaluate 7 cubed, it means 7 times 7 times 7, which equals 49 times 7, or 343. So now let's simplify some expressions with variables. Actually, we'll start with numbers. 0.3, or 3/10, when I raise it to the fourth power, it's 3/10 times 3/10 times 3/10 times 3/10, which is 81 10,000ths. 1/2 to the fifth power will be 1/32. 10 cubed is equivalent to 1,000. And let's look at this next example. You can see how I've written out the expanded form of 5 to the fourth times 5 to the fifth power, which will become 5 to the ninth power. And then when we look closely at the exponents in the original problem, as well as the simplified version, we can see that when we're multiplying two expressions with like bases, we can add the exponents. We call this the product property, or the product rule of exponents. That x to the m times x to the n equals x to the m plus n. So let's apply this product property. Here we're multiplying three factors where x is the base and the exponents are 5, 7, and 2 respectively. So we can just add those exponents and our simplified answer will be x to the 14th. In this example, we have three factors where m is the base and 2 where n is the base. So we'll kind of join those together, and our final answer will be m to the 9th times n to the 13th. So let's move on to what happens if I raise a power to a power, like 2 to the fourth raised to the third power. Well, I've expanded it out to help us remember what we're doing. Whenever you cube something, it means multiply it by itself 3 times. And then I've written the expanded form 3 times over of 2 to the fourth. Our final answer is 2 to the 12th. In the next example, we see that 3 squared raised to the third power is equivalent to 3 to the sixth power. And 4 to the fifth, when I square that, right, will not be 4 to the 25th, right? So I don't square my exponent. Turns out I am going to, in all cases, multiply the exponents together when we're raising a power to a power. So here's the symbolic form of that, and we call this the power of a power property. That x to the m raised to the n power is equivalent to the x to the m times n power. So that's if I'm raising a power to a power. Okay, so what happens if I'm raising a product to a power? Well, I've written out what this means to cube a number. I'm multiplying 5x squared by itself 3 times, and I can expand that and simplify it. And I can see that I could have gotten the answer by taking each factor inside the parentheses and raising them separately to the third power. So this is called the power of a product. That if I have a product like xy, being raised to a power like m, that's the same thing as raising each number, each factor separately to the m power. So we can apply this rule here. I can see that there are 3 factors inside the parentheses. They're each going to be raised to the 3rd power. So it'll be 7 to the 3rd times a cubed to the 3rd times b to the 5th to the 3rd. And then I can just apply my power of a power rule. And my final answer is 343, a to the 9th, b to the 15th. So what happens if I have a negative number, a negative coefficient? Well, I'm going to still apply this same rule of cubing each factor separately. And when I cube -2, the answer is -8 y to the 12th. Now finally we have the power of a quotient rule, which simply states if you are raising a fraction to a certain power, especially if that fraction is inside the parentheses, it indicates that you're going to raise both the numerator and denominator to that power. So we can apply this rule right here. This will be 2 squared x squared over 5 squared. So that's 4x squared over 25.